Hello everyone. This presentation is split into two parts: outdoor water use reduction prerequisite and outdoor water use reduction credit, both of which come under the water efficiency category of LEED certification. In the initial part, we will discuss about the prerequisite, which is a minimum requirement that all projects need to meet in order to achieve credits and subsequently any level of LEED certification. Before going through the actual part, I would like to explain some of the important definitions that will be used in the subsequent slides so that the concept behind this section is easily understood. Grey water. It is the untreated household wastewater which has not come into contact with toilet waste. Hardscape. The lifeless elements of the building landscaping. It includes pavement, roadways, stone walls, wood, and synthetic decking, concrete paths and sidewalks, etc. Landscape water requirement LWR. The amount of water that the site landscape area or areas require for the site's peak watering month. Peak watering month. The month with the greatest deficit between evapotranspiration and rainfall. Potable water. Water that meets or exceeds US Environmental Protection Agency drinking water quality standards. And lastly, xeriscaping. It is the landscaping that does not require routine irrigation. Now, what is the real motive behind this prerequisite? According to the American Water Works Association Research Foundation, 59% of the residential average water is used outdoors. This is in the form of landscape irrigation, which consumes large quantities of potable water, sometimes accounting for 30% to 70% of the water consumed in non-agricultural use. We must all be aware that potable water is a precious resource globally and therefore should be used carefully. This prerequisite applies to new construction, core and shell, schools, retail, data centers, warehouses and distribution centers, hospitality, and healthcare. One important consideration in this regard, however, is that projects with no landscape are exempt from this prerequisite. In order to achieve this prerequisite, landscape area calculations are needed to be done. While calculating this, non-vegetated surfaces like permeable or impermeable pavements are excluded. However, athletic fields, playgrounds, if vegetated, food gardens, and urban agricultural areas are left to the discretion of the project team to consider them or not in their calculations. Okay, broadly classifying this prerequisite has two options. Option 1 is that there is no need of irrigation. For this, the project team must show that the landscape does not require a permanent irrigation system beyond a maximum 2-year establishment period. This must be submitted in the form of documents that shall be shown later in the slides. Option 2 is to reduce the project's landscape water requirement by at least 30% from the calculated baseline for the site's peak watering month. Both of these options will be explained further in the succeeding slides. Let's explore the step-by-step procedure to obtain this prerequisite. Step 1. It is to obtain precipitation and evapotranspiration data which applies to projects outside US only. In this step, you must gather average monthly precipitation data and evapotranspiration rates for the project area to determine the site's potential irrigation needs. For US projects, the tool that is used automatically derives rainfall and evapotranspiration from the project zip code. Step 2. It is to determine the vegetated areas. On a map, indicate all areas on the project site that will have vegetation. When planning the site layout, consider factors such as proximity to water source for optimized irrigation, distance from water meter. Step 3 is plant types and coverage. Identify the plant types and coverage that will balance water use efficiency with the area's intended function. Step 4. Select an option. Option 1 is for projects that do not require irrigation and hence automatically receive the prerequisite. And option 2 has further two steps. Step 1 is to reduce irrigation needs by changing or altering design. This can be achieved by restoring or planting native species to replace areas requiring intensive irrigation. And step 2 of this option 2 is to calculate landscape water budget. Calculate water use as a percentage of total irrigation and peak month irrigation demand using the WaterSense water budget tool for vegetated areas only. Do not include hardscapes. An example will further demonstrate this concept. Now, what is the WaterSense water budget tool? It is a tool that calculates a baseline landscape water requirement of a typical landscape. Different plant species and the arrangement in the landscape can be entered. Design decisions about the different components of irrigation water delivery systems also factor into the estimates the tool provides. WaterSense irrigation controller specifications outline the requirements for weather-based irrigation controller systems. These systems earn projects a standard 15% reduction in landscape water requirement for water efficiency credit outdoor water use reduction. To further enhance our learning of this section and usage of water budget tool that we have been discussing, let's solve an example by taking into consideration a typical suburban community in New Jersey. This has a fairly water efficient landscape and is situated around an office building. Using the WaterSense water budget data finder, we find the peak month, evapotranspiration rates, and rainfall by just inputting the zip code. On the tool, step 1 location and area, we then input the total landscape area and move on to next step. In step 2, plants and irrigation, total irrigation is divided on the basis of plant type and landscape features. As shown in figure 1a, landscape water allowance 30% below baseline minimum equals 43,980 gallons a month. The LWR for this design in this location is 15,939 gallons a month. The total savings from the baseline amounts to 75%. Since only 30% required to meet the prerequisite, the project easily achieves the compliance and is shown in step 3, the results. As discussed before, the required documentations for this prerequisite, both options are shown in the table. Here we have mentioned some of the steps that we can take to reduce outdoor water consumption, especially in lawn and gardens. Number 1. Water the lawn when it's cooler to reduce water loss from evaporation. 2. Do not water lawn on windy days to avoid evaporation. Set up sprinklers so that spraying on sidewalk and driveway is avoided. Turn sprinklers off on rainy days so that there is no excessive use of water. Also, you can use drip irrigation system instead of sprinklers, obviously if possible. And it looks like a small step, but set lawn mower blades as longer grass equals less evaporation. And lastly, use a squeeze, which is also a pistol grip nozzle for hose to avoid excessive water.
So, the previous part of the presentation was regarding how to achieve the prerequisite for the outdoor water use reduction. This part of the presentation is regarding how to achieve this credit. The water use and reduction credit is applicable to new construction, residential, schools, retail, data centers, warehouse and distribution centers, hospitality, and healthcare. One important thing to note here is that we can achieve 1 or 2 points in every category except healthcare. In healthcare, we can achieve only 1 point in this category. We have two options to achieve this credit. Option number 1, no irrigation required. If we have a landscape that does not require a permanent irrigation system beyond a 2-year permanent period, we achieve this credit. We achieve 2 points for each of the categories except the healthcare. For the healthcare projects, we achieve 1 point in this category. Option number 2, reduced irrigation. If we reduce the project's water requirement from a calculated baseline by a certain limit, we achieve this credit. If we achieve the reduction by 50%, we achieve 1 point in every category, including the healthcare. If we achieve 100% reduction, we achieve 2 points in all categories except healthcare, because in healthcare projects, we can achieve only 1 credit in this category. Moreover, we can achieve the reduction in the water requirement in many ways. We can do so by selecting the plant species which are native to the area, or by improving the efficiency of the irrigation system. Also, we can use the EPA's WaterSense water budget tool to calculate the reduction in our water requirements in our project. This is an open source tool which is available to everyone on the internet. We have discussed the WaterSense water budget tool in the previous part of the presentation. Now, we will discuss the steps required to obtain this credit. First, we need to satisfy all the prerequisites. We have discussed the process of prerequisites in the previous section of this presentation. Next, the project team will have to select one of the two options that are no irrigation required and reduced irrigation. If the project team is going with option 1, they have to provide an assessment of the type of plantations used in the landscape and why those plantations will not require irrigation during the project lifecycle. A landscaping plan which shows the provision of native plants have to be submitted to support this case based on local rainfall data and native plants' water demand. If the project team is going with option 2, they have to satisfy the following 6 steps to obtain this credit. Step 1. Reduce irrigation by altering design. The project team have to reduce the landscape water requirements by applying various strategies. We have discussed these strategies in the first half of this presentation. Step 2. We have to consider alternative water sources to provide irrigation. Alternative water sources may include reclaimed wastewater, greywater, captured rainwater, stormwater, etc. See LEAD V4 guide for more examples of alternative water resources. Next step is to consider alternative irrigation controls. The project team can take advantage of latest technology to introduce smart sensor technology irrigation controls. Step 4. Step 4 is to calculate the landscape water budget. We can determine the water saving as a percentage of total irrigation and peak month irrigation demand by using the WaterSense water budget tool. We have discussed about this tool in the previous half of this presentation. Next step is to calculate the adjusted landscape water requirement. We can do so by using the equations used in LEAD V4 guide. These equations allow us to subtract the water obtained from alternative sources and rainwater from the landscape water requirement. The sixth and the last step is to calculate the additional reduction from baseline due to smart irrigation controls. We can again do so by using the equation given in the LEAD V4 guide. This equation allows us to subtract 15% from the prerequisite or adjusted water requirement due to the use of smart irrigation controls. Now, we have to provide the following documentation to obtain this credit. First, we have to satisfy the prerequisite requirements and submit all of its associated documents, and then provide the following documentation to obtain this credit. So this concludes our discussion on the process to satisfy the outdoor water use reduction prerequisites and how to obtain its credit. Thank you for listening.